Hello, math students. Today we're going to be going over the second lesson in the second unit. This one's we're talking more about functions and how they work. And we already kind of talked a little bit about some of that in the previous lesson, but we're going to go into it a bit deeper and just kind of follow along. And as long as you write down everything I write, do everything I do, listen to everything I say, I guarantee you'll have a full understanding and it'll help you in the long run. Especially on those post tests. Okay, so let's go ahead and take a look. I'm on page 5 of the tutorial, and you can see here we're going to look at this question here. The city library is having a book sale to make room for new books at purchase. The graph shows the cost Y in dollars to purchase X books at the sale. So you can see from this graph, if someone were to buy, let's say 5 books, it would cost looks like $2.50, right? So it looks to be about 50 cents per book, right? They buy 2 books, it costs $1. Okay, 50 cents a book, looks like. The cost of the books depends on the number of books purchased. Once again, as we covered in the last lesson, that the x-axis is always your independent variable, and your y-axis depends on your x variable, okay? So the cost depends on the number of books. The cost of the books depends on the number of books purchased. At the sale, each book costs, and we could see 50 cents per book. Okay, once you've gotten that, we can go ahead and skip ahead until where it stops you. You're gonna have to move through some of these pages here, but you can just go ahead until it'll stop you at a question, okay? Okay, let's take a look here. It says, determine which of these relations represents functions and which do not. I'm on page 13 of the tutorial. Then click each relation to find out if you are correct. Okay. So this one is a function. This one is not a function. And the reason it's not a function is because notice this value in the domain 13, it goes 2 outputs, 2 numbers in the range. So if you have an input that maps to multiple outputs, then that's not a function, okay? Now, what about this first one? Well, this one actually is a function. Notice both, but you might be saying, well, both -4 and -6, they both map to 16 in the range. Well, that's actually okay. You can have multiple inputs going to the same output, but you can't have one input going to 2 different outputs. So this is not a function, but this one is. Similarly, when we look at these coordinate points, I can see that this set of coordinate points is not a function because you see -2 has an output of 3, and it also shows -2 has an output of 4. So that same input has 2 different outputs. So that's not a function, okay? Whereas this one is a function. Each input has an output, okay? Similarly, this one is not a function. Again, 4 is repeated here, right? With 2 different outputs. Input of 4, output 20, input 4, output 30. So this is not a function. And when you look at the graphs, this one is not a function. So you could see an input of 6 has 2 different outputs, right? You see an input of 6 has an output here and here. So that double output means that it's not a function, okay? So let's go ahead and go to page 14 and we'll kind of discuss this further. The graph shows the equation x equals y squared. So we can click on this graph here and we should get a graph that shows what x equals y squared here, okay? Now, let's go and answer the question. Use the slider for A to move the vertical line on the graph. According to the vertical line test, is this equation a function, y or y not? Okay, so we can move A, see, use this slider here, and you can see let's just put it at 4 here. You can see that this is not a function, okay? So there's something called the vertical line test, but basically what it states is that if you have, let's go ahead and get rid of this for the moment. If you have any sort of relation, any sort of graph, and you want to see, is it a function or not? What you can do is draw vertical lines. Now, if I draw a vertical line here, notice that when I'm drawing a vertical line here, that's not my best line, but you know what I mean. I draw a vertical line. Notice it has it hits the graph twice. It has two different outputs. That means that this is not a function. This is not a function because it fails the vertical line test. Now, this is not the only vertical line that shows that it fails, right? You could have drawn the vertical line here, and that shows, again, that multiple outputs. In other words, that this fails the vertical line test, okay? So it only takes one vertical line to mess it up, but if any vertical line touches the graph more than once, then the graph is not a function because it fails the vertical line test, okay? So we're gonna go ahead and say that you're gonna state that, just that. So this relation x equals y squared is not a function because it fails the vertical line test. Okay. Note, I could probably make this a little bit better here. Maybe I'll do like this. Oh, there we go. Okay, cool. X equals y squared is not a function because it fails the vertical line test. Okay, and you can see they say the same thing here. All right, let's go ahead and take a look at another graph. All right, this graph is x squared plus y squared equals 5. Okay, so using the slider, move A based on the vertical line test. So we just want to state whether this is a function or not, whether it passes the vertical line test or not. So this graph produces a circle, okay? And you could see that, does this relation, does it pass the vertical line test or fail? Well, once again, it fails the vertical line test because this vertical line is touching twice, right? If it touches more than once, it fails the vertical line test because one input is producing multiple outputs. So we would say this relation, so it'd basically be the same answer, that this relation x squared plus y squared equals 5 is not a function because it fails the vertical line test. Okay, let's go ahead and take a look at this graph, graph C, 2x minus 3. Okay, so we're going to see whether this passes or fails the vertical line test. So let's see, we could use this slider to draw this yellow line. And as you can see, no matter where I put this line, it only touches the relation once, right? So no matter where I put this yellow line, it's only touching this black line once. Therefore, since it's only touching once each time, no matter where I put this vertical line, it's only touching once. So that means it is a function because it passes the vertical line test. So we would say y equals 2x minus 3 is a function because it passes the vertical line test. I don't know how to spell vertical, apparently. Okay. Period, submit. Okay, great. Now let's go ahead and move along to this one here, page 15. Select all the correct answers. So which of these relations are functions? So we want to click all the ones that are functions. Okay, so let's look at this first one, 3, okay, 4, 5, 6. I'm just looking at these inputs, 3, 4, 5, and 6. I notice that the input is not repeating. So I don't have the same input multiple times. Therefore, this is a function. Okay, this one's not a function because see, the input of 2 has multiple outputs, right? The input of 2 has multiple outputs. So therefore, this is not a function because of that 2 there. All right, let's see here. Do we see the x value repeating? Well, yes, we do. See 20 and then 20 here, and they have 2 different outputs. So this input of 20 has 2 different outputs. So this is not a function. Okay. This one would be a function. If we went ahead and graphed this, y equals x squared minus 5, this is a function. We can graph it here. Y equals x squared minus 5. And we could see here that no matter where I would put a vertical line, it would only touch this graph once, right? So if I put a vertical line right here, let's say at x equals 2, right? Notice it's only this blue line is only touching the red line in one location. And no matter where I put this blue line, it only touches the red graph in one location each. So therefore, this one does pass the vertical line test, and it is a function. Okay. Same thing here with this graph. No matter where you drew a vertical line, it would only touch the graph once. So this one is a function as well. The temperature inside a classroom Y is recorded each hour of the school day X. I would say this one is, yeah, this is a function as well, I think, because the time of day won't repeat, right? Let's just make sure that we're correct. Yeah. If your x-axis is time, time should not repeat itself. So, okay. What is the range of this function given the domain? So here they're giving us a domain. These tell us the inputs. In other words, the x coordinates. So for this, we have these various inputs, -2, 0, 2, and 4. And we're going to plug each of these into the function to find the resulting outputs. So let's go ahead and do that. So here's our function, y equals 2x minus 5. Now we're going to replace x with each of the numbers here in the domain. So the first one is y equals, so it becomes 2x, that becomes 2 times -2. And this still has a minus 5 here. So that becomes y equals -4 minus 5. So that's -9. So when you input -2, the result is -9. So I know it's not this one. Okay. All these other ones have -9, so it could be any of them. Let me change my pen color. Now we're going to replace the y, or sorry, replace the x with this input 0. So y equals 2 times 0. I hope you're writing this all down, by the way. Minus 5. That becomes y equals 2 times 0 is 0. Then we have minus 5. 0 minus 5 is -5. Okay, so -5 should be in the range. Okay, so that's got to be this one, right? Okay, and you could check the other points as well. So when you replace x with 2, 2 times 2 minus 5 should give you -1. And then 2 times 4 minus 5 should give you 3. Okay. Go ahead and skip along until you get to here on page 22, and let's talk about this. The output of a relation is the difference of 3 times the input and 5. Okay, so here they're basically asking us to write down the relation. So the output of a relation, so y, is, usually is when you're translating to math, that's going to be your equal sign. So the output, that's y, is, that's equals, the difference of 3 times the input and 5. The difference between, so that's going to be a minus, 3 times the input, so 3x, and the difference between 3x and 5. Okay, so here's our equation. Y equals 3x minus 5. Is this relation a function? So yes, this one's going to be a function, but if you're unsure, you could always go to a graphing calculator and graph it. Now, my graphing calculator of choice, as you probably already know, is Desmos. And let's go ahead and put our function in. Y equals 3x minus 5. 3x minus 5. And so we could see our red line here. This is our function. And yes, it is indeed a function. Notice as I move this blue line across, this vertical line, it only touches the red line in one location for each blue line I draw, right? So when I draw the blue line here, they cross right here, but they only cross once, right? And as I move here, no matter where I move this blue line, this blue vertical line, it only touches the red line once. So it passes the vertical line test. So the relation is a function. The domain of relation is x is greater than 2. So the range of the relation is y is greater than. So for this one, here's our, if we say our domain is only for x greater than 2, well, let's go ahead and plug in 2 and see what we get. So that would be y equals 3 times 2 minus 5. So that'd be y equals 6 minus 5, which is 1. So y equals 1. So when I replace x with 2, the result is 1. So since 2, it's saying my domain is only x values that are greater than 2, that means my range will only be y values that are greater than 1. Okay. Okay, well, with that, that's the tutorial. Now let's go ahead and go to the practice, and then after that, the mastery test. I'm going to be going over every question in the practice. Please follow along. And once again, write down the things that I write, do the things that I do, and it'll make a lot of sense to you. And it'll help you a lot when you do the post-test. Okay? I want you to really understand this material. And the only way you can do that is through practice. Okay, so please practice and follow along. Which of these tables represents a function? So once again, it's a function if you do not see the x repeat. So for example, w is not a function because you see -3 repeated. So -3 repeated, and they have 2 different outputs. Therefore, w is not a function. Okay. For the same reason, notice on list x, 2 is repeated. So this is not a function. Here, are any of these outputs repeated? Or sorry, any of these inputs repeated? No, no input is repeated. So that means this must be a function. Once again, z is not a function. Okay, so y is a function. Okay, again, I want to reiterate that it's okay if the output repeats as long as the input is not repeating. Which of these graphs represent a function? So we can go ahead and make the vertical line test. So select the correct answer. Which of these graphs represent a function? Okay, so only one of these is going to pass the vertical line test. Okay, let me show you the most obvious fail. I think graph Y is the most obvious fail. If I draw a vertical line, notice it touches twice. So this one's a fail. It fails the vertical line test, so it's not a function. Okay, this one's not a function. Similarly, this one's not a function because it fails the vertical line test. So this one's a not as well. Okay, this one passes the vertical line test. No matter where you draw a vertical line, it only is touching once, right? So no matter where you draw that vertical line, it only touches our function once. So this one is yes, this one's our function. Okay, this one's a no as well. A no, because vertical line tests, look, it's touching more than once. Which of the following sets of ordered pairs represents a function? Again, you should see the x coordinate not repeating. So if you see the repeated x coordinate, then it's not a function. Okay. So for example, notice this first list, 10 is repeating, right? You see a 10 here and also a 10 here. So this is not a function. Okay. Also, you can see the 5 repeats as well. So that's not good either. So this is not a function. Okay. This one's not a function because this 1 is repeating. Again, you shouldn't see the input repeating. No repeating inputs. Okay, this one's not, same reason. And this one, 10, -10, 5, -5. Okay, I don't see any repeats for inputs. So that one is definitely a function. Emma bought cashews that cost $3.42 per pound. Which of the following does the situation represent? Both a relation and a function. If it's a function, it's automatically a relation. So every function is a relation, but not every relation is a function. Okay. But this one is a function in this case because it's $3.42 per pound. So for each weight has a different price. Okay. And weights don't get repeated, right? So for a particular weight, it gets a price. There's not going to be like, oh, this weight costs 2 different prices or something like that. Okay, that doesn't make sense. Okay, which of the following is a function? Okay, is this one a function? Well, no, because this input produces 2 different outputs. Okay, so it only takes one guy to mess it up. Okay, once you see one input repeated and going to 2 different outputs, you know that this is not a function. Okay, for the same reason, this one's not a function. Notice this -4, this input of -4 is repeated, so this one's not a function. This one's not a function either. This one looks weird, but notice if I draw a vertical line right here, notice it has 2 outputs, 2 red dots. So therefore, if I draw this vertical line, it touches multiple times, so this is not a function. Okay, that means this one must be a function. And we could check here. Notice none of these are all different numbers, right? -10, -9, 0, 5. These are all different numbers, so different inputs. So this one is a function. Does this equation below represent a relation, a function, both a relation and a function, or neither a relation nor a function? Okay, well, we know it's a relation. We just want to know if it's a function or not. Okay, we know it's a relation. We just want to know, is it a function or not? So one thing, if you're not sure, you could always graph it. Okay, so we have x squared minus 9x. So this is going to, I'm going to go on Desmos, x squared minus 9x. Okay, so, and you could zoom out here, but you should be able to see, yeah, this is a function. The red graph here is a function. Okay. Generally, parabolas like this, if they're going up like that or down, then they are going to be functions. But if they're going sideways, that one's not a function. Okay, so yes, this one is a function. So it's both a relation and a function. Okay. Okay, here we have this line segment. Okay, what is the range? So the range, you look at the y values. So what is the lowest? So again, here's the y-axis. What's the lowest y value that this goes to? Okay, so this is negatives on the y. -1, 2, 3, 4, 5. -5. So that's the lowest value for this function. What's the highest value for this function? Well, it looks like 8, right? So this is 10, it's 9, 8. Okay. So what is our range? It's from -5 to 8. All right. What is the range of this one? Okay, so this one's a little bit different because this one's not a line segment. This one's a line. Notice it has arrowheads at each end, right? It has an arrowhead here and at the bottom. So what does that tell me? That tells me that my graph continues to go like this forever, okay? And continues downward forever as well. So this goes up, 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 up forever, and it goes down, 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 down forever, okay? So what is our range? Well, it goes from -infinity, because it goes down forever, all the way up to +infinity, because it goes up forever. Okay. State the domain and range of the following function. Okay, the domain are the inputs. So in our case, the domain is going to be, and usually we draw a little squiggly if we're just going to have a list. So our domain are our inputs. So that's -9, 5, 6, negative 4, and 3. These are all the x coordinates, the inputs. The range are the outputs. So in our case, that's going to be 3, 1, 9, 7, and 2. Squiggly. Negative 9, negative 4, 3, 5, 6. Here they put them in order from least to greatest, but you don't necessarily have to do that. Given this domain, negative 2, 1, and 5, what is the range of this relation? Okay, so here they're giving us the x values, the domain. Our goal is to find the corresponding y values, the range. So we're going to replace x with negative 2 and figure out what y that is. So this becomes, plugging in negative 2, this becomes 4 times negative 2 plus y equals 3. Now our goal here is just to solve, just go ahead and solve for y. So this becomes negative 8, right? Because 4 times negative 2 is negative 8 plus y equals 3. Now to solve for y, we're going to go ahead and add 8 to get y by itself. Add 8 to get y by itself. Y equals 11. So we know there's going to be an output of 11. Okay, so it must be this one. Okay, but you can plug in the other numbers if you like and solve for y. You should get negative 1 and negative 17. Okay, that was the practice. Now we're going on to the mastery test. Now, you're going to be given 5 questions for the mastery test. I'm going to be going over 20 different questions, but I will be going over your questions. You'll be given a sample of these 20, and you have to get at least 4 correct. I'm not going to go over all the questions in complete detail, but I will give you enough so that you should be able to do it on your own. I'll get you started in the right direction or give you a hint. Some of these I may do in full, so just keep that in mind. Okay, here they're giving you domain, negative 12, negative 6, 3, and 15. Okay, and we want to find, complete this table. Okay, so when I plug in negative 6, so that's one of my numbers from the domain. If I plug in negative 6, I want to find the output here. Okay, so I'm going to plug in negative 6 into my function in for x. So that's going to be negative 2/3 times negative 6 plus 7. Okay, again, just replacing x with this number in the domain. Okay, I'm choosing it from here, right? Negative 6. Okay, now how do I multiply a fraction times a whole number? Well, what you do is you take the whole number, you multiply times the top, then divide by the bottom. Okay, so negative 6 times negative 2, that's 12. 12 divided by 3 is 4. Now it's positive 4 in this case because negative times negative makes positive. Okay, 4 plus 7 is 11. So 11 should go right there. Okay, let me show you how to do one where they give you the y. So in this one, they give you the output, the y. So I'm going to replace the y with 5 in this case. So how does that look? So I'm going to rewrite this, but instead of a y, I'm going to write 5 because that's my y value. And I'm trying to figure out what the x value here is. So negative 2/3 x plus 7. Now my goal here is to solve for x. Okay, we've done stuff like this a lot in the first unit, right? Where we're solving for x. By the way, this concept of solving something never goes away. So my goal here is to get x by itself. Subtract 7 both sides. That gives me negative 2 here. I've got negative 2/3 x here on the right. Okay. Whenever I see a fraction, one thing I could do is just multiply by the denominator. So in this case, I'm going to multiply by 3. That cancels my denominator. Then I multiply this side by 3 as well, giving me negative 6 here on the left equals negative 2x here on the right. Lastly, to get x by itself, I divide by negative 2, divide by negative 2. This gives me 3 equals x. So 3 goes right here. which should make sense because 3 is in my list. Okay. All right. So if you could fill in these other last 2 blanks on your own. Okay. Now you may not have that question, but if you don't have a specific question, I hope you at least still listen to me and see the explanation. It'll give you a fuller understanding of everything that's happening. Drag each tile to the correct location on the inequality. Each tile can be used more than once. Consider the graphed function. Okay, so we have this graph here. Okay, so we want to find the domain and the range. Okay, so for the domain, we look at the x values. So what is my lowest x value? Well, you can see it's right here at -5. Okay, what is my highest x value? Well, you can see it kind of goes up to here to 1, but you notice it's an open circle. So if it's an open circle, we're going to be just using less than. Okay, so less than here, but it'll be less than or equal. I'm used to writing upside down. Less than or equal to here. Okay, so the lowest value in the domain is -5, and the highest it goes up to, but not including 1. So when it's open circle, you don't put the or equal to. Okay, so same idea with the range. We could see we're going to have a less than or equal to here and a less than here. Okay, so what's the lowest for the range? You look at the y values. So what's the lowest y value? What's the highest y value? Put them here. Yeah. Use the drawing tool. All right, consider this linear function. Plot all ordered pairs and the values in the domain. Okay, so here you're going to be using this tool right here, the point tool. So you're going to click on this tool, and we're going to put points on this graph. And we're going to be using this domain to help us. So what I like to do is perhaps on another sheet of paper, you can make an XY chart. Okay, so I'm going to just go and put my numbers here from the domain. I'm just going to put them over here. So -8, -4, 0, 2, and 6. Now we need to find the corresponding outputs, the corresponding y values. So what we're going to do is replace x with each of these values here to find the corresponding y values. So this becomes y equals 1/2. Now I'm going to use that first input, -8, and then +1. Okay, so what's half times -8? Well, remember, when you're multiplying a whole number times a fraction, you multiply by the numerator and divide by the denominator. So -8 times 1 is -8, divided by 2 is -4. -4 plus 1 is -3. Okay, so I'm going to put a point at -8, -3. So I'd click on the point tool. I would go to -8 on the x, -3 on the y, and I'd put a point right here. Okay, I'm going to do one more with you. Replace the x with the input of -4, and we're going to find the corresponding output. Okay, so I'm going to use perhaps blue here. So 1/2 y equals 1/2, replace the x with -4. And then we still have a +1. So -4 times 1/2, that's -4 divided by 2, which is -2, -2 plus 1, which is -1. Okay, so -4, -1, -4, -1. Okay, and so this would be our next point. I want you to find the rest of these points and graph them on your graph here. Now, keep in mind, these points should all line up. If they don't form a straight line, then some of these might be wrong, okay? Select all the correct answers. Which of these relations are functions? Okay, so which of these are functions? So look at this one. We have a repeating x. So is this a function or not? Here, this one passes the vertical line test. So it passes the vertical line test. Each vertical line only touches once. So is that a function or not? Here, each input only has one output. So is that a function or not? Here we see an input repeating. So is that a function or not? Here, once again, we have an input repeating, -5 here, -5 here. So is that a function or not? And here, this one fails the vertical line test because this vertical line touches multiple points. It fails the vertical line test. So is that a function or not? So click all the ones that are functions. Okay. Which of these graphs represents a function? Okay. I'll tell you right now, this one's not a function. Okay. So a straight vertical line is not a function because if I draw a vertical line on top of it, I'm touching it more than once, right? So that's not a function. Okay. This one is also not a function because look, when I draw a vertical line, it's touching multiple times. So therefore, this one's not a function either. So figure out which of these are a function. Number 6, an analyst at a paper company made the table below of the sales by month at his company. Okay, which of the following does data represent? So basically, is this a function or not? So we can look at the inputs. The inputs are the X values. Do we see any X values repeating? No, we do not. So the input does not repeat. So is that a function or not? Okay. And guaranteed, it's always guaranteed to be a relation. So this one's definitely not right. And this one's definitely not right. So it's always a relation. You just need to tell me, is it a relation only or is it a relation and a function? Okay. The domain represents the inputs. The range are the outputs. So for the domain, for example, you would list out all the inputs. So 2 is in the domain, for example, ... And then for the range, list all the outputs, the Y values. So for example, 3 is in the range, ... Okay. Okay, we have this graph. What is the domain? So the domain represents all the X values that can happen. Okay, so let me ask you, is -2 in the domain? Yes, it is, because there's a point there for -2. Is +2 in the domain? Yes, because there's a point there for +2. Is 8 in the domain? Well, yes, because there's a point there for 8 as well. Is 10 in the domain? Yes. Is 20 in the domain? Yes, because this line keeps on going for how long? Forever. These arrowheads indicate that it goes on forever. So what makes the most sense as my domain? So both, I'll give you a hint, both 100 and -100 will be in the domain. Okay, think about it. All right, which of these are a function? Now remember, it's not a function if the X value is repeating. So for example, B is not a function because you see this -9 repeats. Okay. 5x plus y equals 1, the domain, these are your X inputs, your X values. -2, 1, and 6. What are the corresponding range? So you would replace X with each of these values and solve for Y. So for like this -2, you would replace the X with -2 and then figure out what the corresponding output, the corresponding Y must be. So this becomes -10 plus Y equals 1. Okay, solve for Y, and that number, that Y should be in your range. Then replace the X with 1, do the same thing, find Y. Replace the X with 6, find Y. Which of these order pairs is a function? So again, if you see like B here, you see how 8 is repeated. So that means this is not a function. So figure out which of these is a function. Okay, remember the input should not repeat. Okay, does this equation below represent a relation, a function, both? Okay, well, it can't be a function only. And it can't be neither a relation nor a function. Remember, it's always a relation. It's always a relation. So it's either a relation only or it's both a relation and a function. Okay, go ahead and graph it on Desmos, which is this website here. Go ahead and graph it on here and then determine looking at it at the vertical line test to determine if it's a function or not. Mrs. Anderton is giving a test to her third period class. She has decided to record the amount of time that each student takes to finish the test in minutes and compare that to the grade each student receives on the test out of 100. A plot of her results is below. Okay. Does the following situation represent? Okay. It can't be a function only, and it can't be neither a relation nor a function. Remember, it's always a relation, and sometimes it's a relation and a function. Okay. So would this, notice like if I draw a line here, it touches, this vertical line touches multiple points, doesn't it? It touches a point here and here and here. So this vertical line touches multiple points. So is that a function or not? Okay. Which of these represent a function? Okay, so I'll tell you right now that, okay. So remember, if you draw a vertical line, so let me draw a vertical line here. If I draw a vertical line and it touches multiple points, here it touches a point here and here, then it's not a function because it fails the vertical line test. So this one is not a function because it fails the vertical line test. Okay, figure out which of these are functions. Lori is designing a type of candy dispenser for use at grocery stores. When pressure is applied to the lever by the customer, candy will fall into a container. As pressure on the lever increases, so will the amount of candy that is dispensed. For each pound per square inch of pressure placed on the lever, the amount of candy dispensed will triple. This is both a relation and a function. Okay. Because pressure, the amount of pressure you put doesn't repeat and it produces a certain amount of candy. It's kind of a weird question. I really like it. Okay, which of the following represents a function? Okay, remember, if it's a function, that means you shouldn't see the input repeat. Okay, so for example, A is not a function, because you see this input is repeating to multiple outputs. See that? So figure out which of these is a function. Which table represents a function? Okay, so we need to figure out which of these are a function. Once again, if you see the X value repeating, then it's not a function, okay? So for example, this letter Z is not a function because you see this X value repeats going to different outputs. You see that? -2 goes to 2 different outputs. So this double input, that means it's not a function. Consider the following function. Okay, here we go. Using the given function, select the correct set of ordered pairs for the following domain values. So what you're going to do is replace the X with each of these domain values. Okay, remember, these are the inputs, the domain. Those are your X values. So I'll show you what it looks like when we plug in -12 here. So I'm just going to replace X with -12. So for 5/3 X becomes 5/3 times -12, and it still has a +2 there. How do we multiply a whole number times a fraction? Well, it's pretty easy. You just multiply times the top, then divide by the bottom. So -12 times 5 is -60, and then divided by 3 gives us -20. We have a +2, so that gives us -18. So for the input of -12, we get an output of -18. Okay, so the X value is -12, the resulting Y value is -18. Then plug in -3, plug in 0, plug in 3, plug in 12, and 5 in the corresponding outputs, then figure out which of these sets of points is correct. Which of these is a function? Okay, we've done a number of these, but we can see this first one, W, is not a function because this input of 6 has multiple outputs. So therefore, when we see that, this is not a function. Okay, figure out which of these is a function. Okay, select correct answer. Okay. What is the range? Okay, so the range are the y values. So from this point, we're looking at the y value. So that's a y value of 0. And then what's the y value here? Well, that's a y value of what? So figure out which of these shows the correct range. Okay. Now these are full, like shaded in circles. So you want to be using the less than or equal to's. Okay. Because these are both filled in circles. If you see this like an open circle, you would just use these less thans. Okay. But since these are closed circles, we're going to use the less than or equal to. Okay, well, I covered all the questions. I hope you're following along. If you were, and you probably got a really good full understanding of how to tell if a graph is a function, how to tell if a mapping diagram is a function, and what it really means to be a function. Okay, well, if you found this useful, please like, comment, subscribe, or if you really want to say thank you to me, then just share it with someone else. Okay, share it with your teacher or the fellow student. All right, well, with that, take care. See you guys next time. Thanks for watching.